In this mini clip, we will be solving rational equations. While we answer this question together, you'll be solving a similar problem on your own using the same technique. We're asked to solve the equation x cubed plus 2x squared minus 24x all over x squared minus x minus 6 equal to 0, where x cannot equal negative 2 or 3. Our restrictions on x are just to ensure that our denominator is not equal to 0. Remember, we never want to divide a number by 0, which is why we need these restrictions. Taking a closer look at our equation, you should realize that in order to have a fraction equal to 0, the numerator itself must be equal to 0. This is because if the numerator is equal to 0, then 0 divided by any number is equal to 0. So essentially, to solve this equation, we only need to look at our numerator. Once it is equal to 0, our entire equation will also be equal to 0. Our first step then is to set the numerator equal to 0. Our numerator is x cubed plus 2x squared minus 24x, and we're going to set this equal to 0. I would now like you to try doing this step with the question you are given. Here's the answer you should have got. Coming back to our equation, we now want to find all the possible values for x that make the left-hand side of this equation equal to 0. In order to find these values, we need to factor. So this will be our second step. When factoring, we always want to first find the greatest common factor. In our trinomial, or our three terms here, the greatest common factor is x. This is what we would like to first factor out, the greatest common factor, which in our case is x. I'm going to write a bracket here. To determine what's in the brackets, we need to divide our trinomial by the greatest common factor, which is x. Our first term then will be x cubed divided by x, which is x squared. Our second term will be 2x squared divided by x, which is 2x, and we will be adding this term. So plus 2x. And our third term will be 24x divided by x, which is just 24. And we are subtracting this number, minus 24. And it is still equal to 0. Now try doing this step with the question you are given. Here's what your answer should look like. Now coming back to our question, we will realize that we can further factor what's inside our bracket. This trinomial is called a simple trinomial. This is because of the 1 that's found in front of the x squared. To factor a simple trinomial, we need to find two numbers that when multiplied together give negative 24, but when added result in positive 2, this middle term. So we need to find different combinations that we can use to satisfy this. So for example, we can try 12 and negative 2. 12 times negative 2 will give us negative 24, but if we were to add 12 and negative 2 together, we would get positive 10, not positive 2. Therefore, this combination doesn't work, and we need to try and find two other numbers. Let's try 6 and negative 4. 6 times negative 4 will give us negative 24, and if we add 6 and negative 4 together, we get positive 2. These two numbers do work, therefore we will use them to factor this trinomial. So we're going to have the x left out here outside the bracket, In our first bracket, we're going to write x, and beside it we're going to write our first number, which was positive 6, or plus 6. In our second bracket, we're going to have x, and beside it we will write our second number, which was negative 4, or minus 4. And I'm just going to write equals 0. Now try doing this step with the question you are given. Here's how your fully factored expression should look like. Now we have three numbers multiplied together. We have x times x plus 6 times x minus 4. To have this product equal to 0, one of our numbers that are being multiplied must also equal 0, since 0 times any number is equal to 0. This means that either x must equal 0, x plus 6 must equal 0, or x minus 4 equals 0. So I'm just going to write this out here on the bottom. So our three possibilities were that either x is equal to 0, x plus 6 was equal to 0, or x minus 4 was equal to 0. The last thing we need to do is to determine the value of our x that makes these expressions equal to 0. In other words, we need to isolate for x. So, x equals 0, this is already done for us since our x is isolated. In this expression, we need to find out what value of x makes this left-hand side of our expression true, equal to 0 in other words. So what we need to do is just isolate for x. So we bring this 6 to the other side of the equal sign to find that x is equal to negative 6. We bring it to the other side, remember, it changes signs. So when x is equal to negative 6, this side of the equation equals 0, which makes sense since negative 6 plus 6 equals 0. Our third expression, we need to solve for x again. So we need to bring this negative 4 to the other side of the equal sign, and we will find that x is equal to positive 4. So we know when x equals 0, x equals negative 6, or x equals 4, our original equation will equal 0, and this will be satisfied. Now I just want you to notice that these three values for x satisfies our restriction, since none of these values are equal to negative 2 or 3. So these three possible values for x can be used in our final answer. So I'm just going to write a therefore statement now. So our possible values for x are negative 6, 0, and 4. I would now like you to find the final solution to the question you were given. And here's your final solution.